Well, thank you everybody for joining us on another episode of DNS Unfiltered. I'm joined today by a very special guest, Richard Hipp, the basically the inventor of SQLite. He's had a long history in the world of technology. He built the most fundamental database, and the story of how it was built is kind of interesting. But Richard, why don't you tell us a little bit about yourself and how you got started in tech?
Yeah, sure. Thank you for the introduction. My name's Richard, and I live in Charlotte, North Carolina. I took a PhD from Duke University in 1992, but recognized immediately that I was not a good fit for the academic world, and so I started a business, just building bespoke software for people. This was back when we still used dial-up, okay? And I did that for a number of years. And in the course of doing that, at one point, I needed an embedded SQL database engine. And by embedded, I mean it's built into the same process. There's no separate server. And there was none available. And so I thought, oh, I'll just write my own. And so how hard can that be? And so I put together SQLite, and I put it out there as open source, thinking it would get about as many downloads as every other bit of open source software I'd ever put out there. 5 to 10 downloads per year. But it went viral. And after a while, companies started calling me up and said, can we purchase support for this? And I was thinking,
why would you want to do that?
Well, you can make money on open source software? Who knew? How much would you charge for that, sir? Let me get back to you on that tomorrow. And then I frantically searched around looking for, some kind of reasonable price. Anyway, long story short, it turned into a business. And I haven't done any bespoke software for decades. The business since then has been purely supporting and continuing the development of SQLite. SQLite started in the year 2000, but we really didn't really turn into a business until about 2004. So it took a few years to kind of catch on. But since then, I've been able to support a small team, and we work on it full time. And it has been so much fun.
That's really cool.
The open secret is that nobody on our team has any formal training in database technology.
Really? That's how simple SQLite is.
Well, it's gotten a little bit more complicated over the years. It's a constant struggle to keep things simple. But yeah.
Wait, one quick clarification. Do you say SQLite or SQLite? I've actually heard lots of pronunciations.
You can pronounce it any way you want. I say
no. I want to pronounce it the way you pronounce it.
I say SQLite.
Oh, okay.
Like a mineral. SQL.
That is the only pronunciation I've never heard. SQLite.
Right.
Very cool. So the name of your company is Watchy. You run it with your wife and a small team, and you guys have been able to, build such a robust, not error proof, of course, but minimal errors based on a massive, extensive testing suite that I understand is pretty comprehensive.
Yeah, that's the key I've discovered. And see, when I first started this journey, there's something about PhD programs in the United States. When you come out of one, you have this idea that you know everything and that you can do no wrong. And that's the lesson that I took out. Oh, I had that. I was definitely thinking that I knew everything. And you just have to spend a few years in the real world to get the right correction on that. So
yeah, it doesn't take long. You get slapped in the face pretty fast.
Anyway, but even when I was writing SQLite, I thought, I can write software that doesn't have any bugs in it. And I felt like SQLite was just bug free. And then in the early 2000s, it started being adopted by all these cell phone companies and for use in handsets, and there were hundreds of millions of devices being deployed with it. And it turns out that when you deploy 100 million or a billion instances of an application, a lot of really obscure bugs will pop up. I was shocked, and we there was a period of time there where we were just getting all kinds of bugs. And about that same time, I had a contract with an aerospace company, and I learned about DO 178B. This is the engineer or the quality control spec for avionics or avionics software. It's been superseded by DO 178C now, but it's essentially the same thing. And you have to pay for these, and I wasn't willing to pay to get the new version, so I'm still using B. But it defines a number of things for safety critical software. And one of the things it talks about is 100% MCDC test coverage, or modified condition decision test coverage, which is complicated, but it basically boils down to every branch instruction at the machine code level both falls through and the jump is taken at least once within your tests. And I thought, well, I'm going to implement this. And my idea was that, I'll do that, then I can sell DO-178B artifacts to aerospace companies and make millions of dollars. So the second part of that did not really play out.
But
total sales of that have been zero. Okay, so that didn't really work. But it took a year to really develop this test suite, and that was a hard year. I was working long days, 6 days a week. But at the end of it, this constant stream of bugs that we were getting from Android just kind of stopped. I was shocked at how well that level of testing actually worked. And of course, the original idea was to keep the test suite proprietary because we were going to sell it. Well, that didn't really work out, but I've kept it proprietary because that's sort of the company assets. That's our intellectual property. The SQLite source code itself is in the public domain. Anybody can take it. They can fork the source code.
Mm-hmm.
And we do have a lot of tests that are there in the public release, but they don't provide the full coverage that our proprietary tests do. But anybody can fork it and take it, but they can't get a hold of our test suite. And that gives us a little bit of leverage that kind of keeps us in control. I wish I could claim that I had the idea of doing it that way from the beginning, but
it wasn't in your business plan at the beginning.
Really, no, it was not in my business plan at all. No, and I had no idea that you could do something like that. It worked out. I call it divine providence. I mean, I didn't plan this. It worked out really well. If I had it all to do over again and know now what I knew then, I don't think I could have done any better. So
I would agree with that. And for those listening that are not very familiar with SQLite, SQLite. It is basically the most widely used database on the planet. It is the backbone of most apps on mobile devices. It's used in a lot of places, a lot of embedded places. And you manage it with a small team. It's open source, but there's no like public contributions. Like you and your team manage all of the commits essentially to the source.
Well, now let me correct that slightly. That's a common misconception that we just refuse all contributions. And that's not strictly true. The thing is, it's in the public domain. And so in order to take a contribution, we have to make sure that contribution is also in the public domain. And so we do occasionally take contributions, but there's a lot of paperwork. There's a lot of hoops that you have to jump through. in order to.
You're making me want to ask the question, who is it that's contributing to the source of SQLite?
Well, some big companies have contributed to it.
I imagine so.
There is code in the tree that was contributed by Apple, and there's some that was contributed by Google. And we had meetings with lawyers, and there were signatures, and I've got documents in my fire safe right across the room over here that show that this is in the public domain. So, and there's a list. I think it's 20 odd people who have contributed over the years.
Yeah,
but
and I think the point is like SQLite is, I mean, it's kind of a global treasure, for lack of a better term. Like it's very important to our computing world. It's usually the backbone, the database for like local apps. Like a lot of Apple apps use it, which is why they would want to contribute to the source. And I was really curious to ask you about this idea of simplicity. Like the SQLite is a C library. It's like, basically a single file database. At least it appears that way when you're utilizing it. Very simple to operate. Very much like any other database of that nature. But there's this simplicity that only it has versus others. Like there's no server to run, nothing like that. And this idea of simplicity with your business, the SQLite code itself, the deployment, and this idea of simplicity, like simplicity is just like a timeless, has timeless appeal, like, a fine watch or something. And I'm curious, and addition to that, I have seen this proliferation in recent months, maybe years, of not SQLite making a comeback, but in a way, it is kind of being becoming more mainstream. Like it's now included in the download for Rails 8 and other software frameworks because people have recognized its its simplicity, and that perhaps this hyper scaling world is not always necessary.
Yeah.
So can you talk a little bit about that?
Sure. Well, of course, the original idea was, kind of the slogan was, SQLite is not meant to replace Postgres. It's meant to replace fopen, in the sense that a lot of people, maybe not so much now, but 10 or 20 years ago, people would, I've got to store some data. I'm going to open a file, write some data in my proprietary format that I just now invented, and save it that way. And that was real common. I did it all the time myself. But my argument was a better choice would be to store it in an SQLite database. So we weren't competing directly with the client server databases. They had more concurrency. But over the years, and that's the purpose SQLite serves. And so that works really well on like a mobile phone. I mean, how many concurrent users do you have on your mobile phone? Do you really need to support 100 concurrent users? So SQLite works really well in that. I used to sell it as the SQL database for edge devices. The database on the edge. Other database engines, they would work in the data center, in the big server and the lovingly attended, environmentally controlled data center. SQLite's working on little Raspberry Pis out in the elements, out on its own. No database.
Like a weatherproof enclosure and an antenna.
That's right. That's where it was used, and it was designed for that purpose. And what we found more recently is that with computers have gotten so fast that, and SQLite has arguably gotten better and faster itself, that for many applications, SQLite is a sufficient replacement for the traditional client-server database. Now, the advantage of a client-server database, and I use Postgres as an example all the time, is that you can really scale it up much better, much bigger. You can have multiple concurrent writers, and you've got all kinds of enterprise features, hot failover and backups and so forth. And SQLite just doesn't do those things because that's not really part of its mission. But the increasingly, there's so many apps out there, the machines have gotten so fast that what SQLite does do is sufficient for most use. So for the example, the SQLite website itself is, of course, backed by SQLite. That would be.
Of course.
And we get, I don't know, 10 requests per second of for non-static files that have to involve the database on average. Each one of those does, on average, about 200 queries. So we're getting up 2,000 queries per second, and this is on just a rented shared server at Linode. I mean, it's not a big machine, and we get tens of thousands of visitors per day, loading about 10 gigabytes or more content per day. So it's not a huge website, but it's not trivial either. And there are a lot of websites that are much smaller, and they can easily use SQLite. The advantage of SQLite is, as you point out, is so much easier to administer. There's less to install. You can have in your head at one time an idea of everything that's going on. The idea is that each of us has a limited amount of bandwidth in our head, and the more of that bandwidth fraction that you use to think about how you're configured your database, the less is available to solve the actual problem you're trying to solve.
Right.
And so if you can simplify the database so that you don't have a separate server to deal with and config files and all of that, it's just a file on disk, that just it simplifies the mental model to the point that you can think more deeply about the core problem. You can better solve your customer's problem. A key differentiator of SQLite is that the database file itself is a single file on disk. If you're working with MySQL or Postgres or SQL Server, where is the database exactly?
Especially if it's like running in a Docker container or something. You're like,
Yeah,
I can barely find these files.
Can you point me to where that database is? Yeah. If I wanted to make a tarball of the database, how would I do that?
Or like even like a simple backup.
That's not a real clear thing. Whereas with SQLite, I've got an icon on my desktop that is the database. And if I want to move it somewhere, I just drag it. It's that simple. And people are discovering that having that simplicity of the mental model to be able to point to something and say, this is the database, really helps them to think deeper about the problems they're working on. Of course, the cost of that is that it doesn't scale as big because an SQLite database is limited in size to how much you can store in a single file. Whereas Postgres, you can spread the database across multiple disks or whatever you need to do in order to have truly massive databases.
But you can like optimize SQLite for speed, like using the wall mode and some of the other pragmas. Like I'm just scratching the surface on this for an app that I was trying to build, a personal app that I was trying to make. And I was like, I didn't need all of the performance, but of course I wanted to give it a shot, and it's working, and it's fast, and it's great.
Yeah. As so many things, wall mode seems to write ahead log. So the default behavior of SQLite is that it uses what's called a rollback journal. At the beginning of each transaction, as you start modifying the databases, before it modifies a page, it makes a copy of that page into what's called a rollback journal. And so if the transaction fails, if you have to roll it back, or if you take a power loss or something like that, on recovery, then you've got the original database, and you can restore the database to its original content. Write-ahead log is kind of the opposite, where it, instead of making a copy of the original content, it writes the new content into a separate log file, the write-ahead log, or the WOW file. And then later on, there's a separate operation called checkpoint, which takes the new content and folds it back seamlessly into the original database. So write-ahead log is a better approach. The default is still rollback though, because write-ahead log requires a small amount of shared memory between every process that's using the database. And that works fine as long as all of your database users are on the same machine.
Mm-hmm.
But if the database file is on a remote disk and it's being accessed by 2 or more machines, they obviously cannot share memory. And so write-ahead log mode won't work there, and you'll get database corruption.
But the funny thing is, with SQLite being the nature that it is, and I've seen this with NoSQL databases, is like if you had a multi-tenant app, which most apps are, like you have an account, blah, blah, blah,
yeah.
you could have a database for that account. So
Yes.
they're technically the only people writing to that database.
Sure. And like on your phone, for example, I mean, does anybody really have multiple hosts sharing the file system of your phone?
Not
I
using
don't
at the
think
same
so.
time, for
That's
sure.
not a typical scenario. So yeah, and people argue, well, we should make the write-ahead log mode or wall mode the default. But if we do that, there are people who have their databases on an NFS mounted disk somewhere, and they will suddenly start breaking. And I'm hesitant to do that.
Just put the database with the code; it's fine.
Yeah. So, but no, once you turn the write-ahead log mode on for a particular database file, it remembers. You only have to do that one time, and so it remembers moving forward, and that's what most people do. And I believe that you mentioned that it's now in Rails 8, and amongst the things they needed to figure out in Rails, the Rails people, was that, oh, we need to make sure when we create new databases they're in wall mode, otherwise we don't get as good performance. Did I mention that wall mode does give better performance? Or for write performance.
Right. And the thing is, and I want to kind of call this out to the audience. I pitched this to Richard, saying that I wanted to talk about the simplicity and how it's becoming more in vogue in the tech sphere these days. With things like SQLite making a resurgence and Rails 8 batteries included frameworks type of stuff. And you were like, I don't know how much I'm going to be able to contribute to that conversation. But I don't think maybe you just realized it, maybe you haven't yet, but I'll call it out that your strategy with this whole database is the strategy that is now in vogue. People are finally catching up to you, 24 years later. You're ahead of your time then, and you're ahead of your time now, sir.
Well, let's just say I need to keep things simple so that I can keep it in my head. Okay, I just I don't do well with excess complexity. I need to keep things simple for me.
Yeah, and that's the case for everything, like development, computers, technology is all getting very complex. And it's nice to see this resurgence happening. But I am curious, like, what do you think people make as like misconceptions when they're thinking of like going to build something, not necessarily an application, but like maybe just a business in general? What do you think some of the mistakes people make are?
For building a business, oh, you do not want to come to me for business advice. Okay,
Well,
that would be a mistake.
You accidentally have a successful business.
No, yeah, it's divine providence. That's the only reason we're successful. Okay, it's not by any skill of mine. No, I think keeping things simple is I think that's always been an important thing, and this is why computers exist, is to keep things simpler. I don't know why people want to layer on complexity. That just boggles the mind. And really, there's a struggle. There's a constant struggle in SQLite. Do we add this new feature, which might be useful to some people, but it's another API to keep up with, and And once we add a new feature, I've got to support it forever. And it becomes more and more complicated. And so this is a constant battle. The original version 1.0 of SQLite had 5 APIs. There were 5 entry points into the library.
It was like read, write, update, delete.
Open, close, and exec, I think. And maybe a couple others. I don't remember what they were. But now there's over 200 different ways to interact with the library. And how do you keep track of all of that stuff?
Well, I understand you have more test code than the code base.
Yes.
The test suite is larger with your, was it MD? What'd you call it?
MCDC.
Aerospace.
We have 100% MCDC test coverage. It takes an hour, a little over an hour, running in 24 cores to run the entire test suite.
So there's all this pressure for you to add new features. Apple calls you, like Uncle Tim calls up and says, "Hey, Richard, we really want this thing." Like, how do you?
I've never actually talked to Tim, but
I'm sure I know.
No,
someone from
it is
Apple.
funny. We matriculated at Duke at the same time. We probably bumped into each other at some point, but I don't know.
But Apple calls somehow and they contact you and say, "We would like to add this new feature." They maybe provide the code to you, like, this is how we would like to improve it. And you and your team have to weigh this, do we
want to do that? Yeah,
exactly. So how do you manage that? How do you assess that it's worth adding or not?
You have to, there's no cut and dry formula. I don't have an algorithm to determine what to do. You have to kind of weigh the advantages and disadvantages. For one thing, I have promised to try to support the code through the year 2050.
Yeah.
So I got 26 years more of support. So anything I put in, I've got to support, we're not even at the halfway point yet. And there's a lot of things that have gone in over the years that I deeply regret putting in.
That you now can't remove.
That I now cannot remove, exactly. And so I look at those lessons and I say, do I really want to support this for 26 years? Is this, and I have to think, how many people in the world is this going to benefit? What is this? Is this feature going to solve more problems than it creates? Really? And I think and solve more problems than it creates in the long term. Yeah, it might solve one problem right here today, but what about all the problems it's going to create across the next 26 years as we have to maintain it and there's bugs in it and we have to fix those and so forth? And that's, I wish I had a good solution for how to decide what to do that. There has been feature creep, and so the interfaces become much more complex over time. And we've got like hundreds of compile time options that you can select, because some people can go, "Oh, we really need this obscure feature." Well, I can give it to you as a special compile time option that's off by default. And we do some of that, but even then, we have a bunch of if-defs in the code, which make the code hard to read. So you've got to be mindful of that as well. I don't know. A part of the solution is to keep the design very simple and flexible to begin with, and to the ability that you're able to foresee the future. That helps. And I did part of that right.
Accidentally.
Some of it I did not do very well. There are places in the file format that I desperately wish I had done differently so that we could extend them at this point. But it is what it is. We have to live with the choices I made back in the early 2000s.
Well, I would say they're mostly good from what I can see. I'm sure you get a little nervous every day when you have to look at that code again.
The point is the database file itself is a well well-defined format. And there have been multiple people who have written independent implementations for reading that file. There could be people who've written ways of writing that file that I just don't know about. But there are independent implementations of the reader based only on the spec, not looking at the code. And you can take a database file from 2004 and read it in the very latest SQLite, and it works fine. And to some extent, going the other way, you can take a modern database and read it and write it using a 2004 version of SQLite, as long as it doesn't use any of the newer features that we've added.
Mm-hmm.
But there were a lot of mistakes. Like, in 2004, all the Macs were still running PowerPC, which is a big Indian processor, and the internet is big Indian. And so I made the database big Indian. And of course, since then, everything has
Indian.
it's gone little Indian. And so whenever you're reading and writing SQLite, you're always doing it byte swapping. You wouldn't believe how many CPU cycles we spend byte swapping in and out of the database. Why didn't I make it little Indian to begin with?
Well, maybe in 2051 you can fix that.
I don't know, but if it had gone the other way, if the world had gone to PowerPC rather than Intel, that would have been a good choice maybe, but I don't know.
Well, it sounds a lot like this idea of simplicity is really just like our humanity. Like what you talked a little bit ago about like the bandwidth of your brain essentially. And like you probably have most of the SQLite code base in your brain, or at least know like where to find sections and things like that. But once there's pieces that there's no room for, and you can't write tests for that you feel comfortable with, then it's like off the table. That sounds like maybe the algorithm you're using, perhaps.
That's certainly part of it. Yeah, that's not exactly the algorithm, but we'll take that as a good first approximation. You're
like, not bad. Bad for a marketing dude.
Well, no, when this comes up, I ask the team, hey, do we really want this? What are alternatives? And we talk about it for a while. A lot of times we'll come around with a way of solving the problem without changing the code.
Wow.
An example of this, 4 or 5 months ago, somebody came in and said, look, you really need lateral joins in SQLite. And so I created a branch and I implemented lateral join. But it's still on a branch. I have not landed it on trunk. It works great, but I can't really come up with a compelling reason to use lateral join. I've asked around, hey, does anybody really need a lateral join? Is this, it's part of the SQL standard, okay? But does anybody ever really do it? Why should I complicate the code with this? I keep the branch up to date. Every now and then I merge from trunk into the branch so that it still works. And maybe it'll land on trunk at some point, but I'm torn. Once I merge it onto the trunk and it gets into a release, I'm stuck supporting it until the year 2050. Do I really want to? And I haven't reached a conclusion. The algorithm has not yet converged.
I see. Let's dig more into the idea that you just said about fixing the problem without changing the code. So in the example you mentioned, you wrote some new code, but have yet to merge it into the core. But what are some other things that are like not fixing the code that solve the problem, like documentation, things like that? What
Right, document things better. Show people how to solve their problem without the feature they're asking for. Show them how to use existing features to solve their problem.
Yeah. So we at DNS Filter, we have an application. We do DNS resolution. And a lot of times people ask us for feature X or Y. And a lot of times it's like, well, if you use feature Z and R in this way, you get feature X. And they're like, but we want X.
And I come back and say, yeah, but I want to support this for 25 more years. If you're going to pay me to support this for 25 years, we'll talk. Otherwise.
So SQLite is really about its lack of complexity, which results in very high reliability. So do you think this simple by design naturally leads to reliability?
Let's call it no, not natural. You can still have very simple software that's very unreliable, and it's also possible to build complex software that is very reliable. My second thought was, we're going to say that simplicity is a necessary but not sufficient condition for reliability. But I think that simplicity and reliability are correlated strongly. I think the best thing to do is to keep things as simple as possible. I was watching an interview on YouTube. Some podcaster was walking through the SpaceX facility with Elon Musk, and Elon Musk was saying, and I thought this was a great idea. He said he's constantly pushing engineers to take things off of the rocket. And he says, if you're not having to add back about 10% of the stuff you're taking off, you're not taking enough stuff off. And,
So simplicity is
Elon's about
strongly
crazy, but even crazy people have great ideas, and he does land rocket ships. So
yeah, that was
he's worth listening to. Take stuff off. What can you reasonably remove from this product and it still do its fundamental job? What is your core functionality? What are you trying to? What is the problem that you're really trying to solve, and do you really need this other feature in order to solve that problem?
100%. So simplicity is strongly correlated to reliability.
I would say so,
but
yes.
simplicity is also a struggle in itself to retain. And
because the point of this is to improve humanity or to promote the flourishing of humanity. And so you get all this feedback from a lot of people saying, we need this, we need that, we need this. And you want to provide for these needs. But sometimes it's better to say no. What I have discovered in being a leader of an important project like this is that the most important words of a leader is no. It's very important to say no. And looking back over the years, I've recognized I haven't said no nearly as much as I should have.
Well, that's definitely going to be a clip from this episode. and real quick, I've seen an interview with Elon Musk when a reporter was walking around with him around the SpaceX facility, and he was telling him how things operate, and the reporter said, I forget exactly, but he was like, why don't you just do this thing? And Elon goes, huh. He walks away and goes to tell some engineer what the reporter just told him. So it's solutions can come from any angle.
Yes, and that happened. That's happened to me actually. Yeah.
Fun story there, or nothing you can say?
Well, it's just a story. It's not worth repeating. No, but no, I was talking to back years ago. I was talking to I was in Virginia talking to AOL. Remember America Online?
Oh yeah.
And they were out of there by Washington, just west of Washington. I forget the name of the town. Anyway, I was up visiting them and I was talking about this or that feature, and I was talking about some new feature I put in SQLite. In mid-sentence, I recognized, there's a bug in this feature. That's not logically sound.
You're like, hold on, I'll be right back.
And without breaking stride, I managed to shift the conversation around and then go back and take that new feature back out. But it's similar kinds of things. Yeah, just people have come in and said, hey, have you thought of doing this? And I said, well, no, that won't work, and here's why. And Oh wait, maybe that will work.
As you're explaining why it won't work, you start to realize,
Yeah, maybe
actually, that's a
that
great
will work actually.
idea. I say that to my son. He's 3. I'm like, that's a great idea. Like, what are, things that just to get him a
Hmm.
win, get him a
So
win.
we appreciate all the feedback. We do.
So let's talk about the adoption of SQLite real quick before we go. Um, you know, I don't know how many installs there are. Maybe you do, but it's a massive deployment base. The code's freely available, easy to install. You can run a simple command and get it in almost any software package. How do you think that adoption happened? It's probably the most well-used database on the planet.
I,
How do you think
I'm
that
going to
happened? I know it
claim,
was accidental, but there has to be
yeah,
some.
I'm going to claim that there are more instances of SQLite running right now than all other database engines combined. And of course, I can't prove this, but think about it, there's multiple instances running in your iPhone as we speak, or your Android phone. They're running in this web browser that we're using to record this podcast. They're in all of your devices. They're probably in your microwave oven. It's certainly in your car. They're everywhere. Um, there have been a couple of studies of this, and roughly speaking, half of the file system I/O on Android and on iOS is SQLite. To a first approximation, um, file system I/O is either media files, videos and audio files and stuff, or else it's SQLite databases. Now, there are other things happening as well, but they're they're insignificant in comparison. Yeah, it is the most widely used ever. How did that happen? And of course, once again, I'm going back to divine providence. I wish that I could say that I had planned it this way and it was going to work out. But we had the right product at the right time. It was there. It was starting to mature just as iPhones were taking off, or just as cell phones were taking off. Android and iOS were just starting to spin up. Um, when SQLite was getting started, and it was the only SQL solution available on the phone at that time. Uh, I say that I think there were some others that were kind of obscure. Um,
Yeah.
Back early on, I got a call from Symbian OS. Do you know about Symbian? You
Yeah,
may
they
have been
were one of the other handset makers like Motorola or
right.
something.
Yeah, that was the operating system in Nokia phones for a long time, and several other brands as well. And they were based out of London, and they called me up and said, "Hey, we want to have a meeting. Can you fly to London?" And apparently they they had their own proprietary database. They wanted to move to an SQL solution, and they found 10 different SQL solutions for their database on Symbian OS. And they had a big bake-off where they were going to test the performance and features of them all. And as they tell me, the other 9, they had talked to the vendors and gotten them to help optimize it and do well on the benchmarks and stuff. And I'd never heard from them. They didn't talk to me. But SQLite still won. And so, we came out on top, and they wanted to make SQLite the default database in Symbian OS. And um, so that was, part of what helped me convert and make SQLite into an actual business. But the point is, there were several others at the time, but SQLite was sufficiently better that we were able to beat out all of the competition. And today, are there any other SQL databases that compete with SQLite? I mean, yeah, sure. There's a lot of
No, like homegrown, one-off type of things, maybe, but
yeah, there's a lot of client server databases. There's still definitely a place in the ecosystem for Oracle and SQL Server and Postgres and MySQL. Those are very important products. I don't claim to replace any of those. But are there any other embedded SQL databases? I don't think there are. If there are, I don't know about them.
So a little bit of divine intervention, a little bit of right
Yeah,
place, right time, that
yeah,
simplicity mindset that you
yeah.
just
No, I'm
like as a person.
if there's no, I'm utterly
I'm,
convinced that if I had set out to actually make this happen, I would have failed
it would
utterly.
never happen. They'd be like,
No, yeah,
Richard, you're crazy. This is never going to work.
yeah. No, it is crazy, and people in part of the reason it was successful. Um, I mentioned earlier that none of the team has any formal training in database technology. But at the time, all the database technology was happening at up in Cambridge at Harvard and MIT, or out on the West Coast at UC Berkeley. And if you weren't plugged into one of those schools, you really didn't have access to the information. We didn't have Google back then. We couldn't just Google and pull up the papers. You had to actually go to a physical library and pull books and articles. And I went to the local university library, and there was nothing that I could find. And so I had to invent SQLite entirely on my own, and which was good, because if I'd studied the literature, I would have quickly realized that this was impossible for one person to do. That I would have given up the task from the very get-go.
And that no one would probably use it.
Yeah, and it would never work right. So I would have never attempted it if I had known what it was I was getting into.
Yeah, the best things are accidental from
Yeah.
what I've seen. I'm curious. So I've seen like cloud hosted subscriptions for SQLite these days, which I think is crazy. It's kind of an odd thing to have
I
cloud
don't
hosted,
really understand that.
but you've seen them too. So I'm
Yeah.
like, and actually, when I was trying to get some of the performance features teased out of my Python code, they had good articles on how to use SQLite, performance and blah blah blah,
Mhm.
which was helpful. But I was like, why would I use this cloud thing? But anyway, my point is, like, there's something happening where things like SQLite are becoming a cloud hosted solution. Somebody's going to be providing this to people. But I'm curious, like, what else do you think is around the bend for SQLite? Until 2050 at least.
You're asking me. I didn't predict SQLite was going to be successful to
You're
begin
like,
with.
I have no
So
idea.
I, SQLite in Rails 8 by the default. Really? I mean, I'm
Yeah.
honored. I really am. But who knew that was going to happen? Um, I don't know what the future holds. I'm for the longest time I thought this has been so much fun working on SQLite and getting to develop it, because really at the end of the day, I'm just a coding geek. I write and really enjoy writing software. I mean, even if I had to have some other job, I'd write software on the weekends just because I enjoy doing it. The fact that I can get paid to do it, that's just really special. But every morning I wake up and think, well, this will be the day somebody comes out with a revolutionary new product that makes SQLite obsolete, and the business will kind of shut down, and that'll be that. But it's been a fun ride. And I think this like every morning, but so far we're still here. I don't know. Will somebody come along tomorrow and have the revolutionary product that replaces SQLite? Maybe. But if I knew what that was, I'd try and beat them to it. But I don't know what that is.
You're like, I accidentally did this. Maybe I'll accidentally do the next thing. I don't know.
Yeah.
So I'm curious. One last question. You have a lot of simplicity and reliability kind of baked into your business, into SQLite, and your corporation is HWACI.com, which is pronounced
That's
Wachi.
the official name is Hipp, Wyrick and Company Inc.
Mm-hmm.
WACHI is the acronym. Wyrick is my wife's last name.
Yeah, your wife Ginger plays a role, and she's like a musician, from what I can tell.
She is music faculty at the local university and a musician. But it's so we're yin and yang. I mean, a musician and a computer
coding
geek. I mean,
geek.
but but it's very complementary roles, and I picked up so much music, living with her for decades out of mine, and she's picked up a lot of computer stuff. So any musician in town, they know to call Ginger to find out. If any musician in town has a computer problem, they end up calling Ginger to get the solution.
To get to you.
Because she's kind of picked it up. I mean, she's not a programmer or anything like that, but she's picked up so much stuff, and she can explain it to them as a musician, whereas I could never explain it to them.
she can translate it into English, basically. Is what you're saying.
Exactly. She translates into human. Yes.
Human. What do you think some of the habits are that you have that, accidentally made this a successful endeavor?
Yeah, I could do a real lecture on that. Here, just some design rules. Solve more problems than you create. That's the key to success in anything. Solve more problems than you create. And if people would do that more, the world would be a better place. And the other thing that's been bothering me lately is people, they're not willing to take the blame when they do something wrong. It's always somebody else's fault. My life isn't going well. It must be somebody else's fault. Who can I blame? Well, even if it isn't your fault, you ought to take the blame yourself if you want to work past it. You've got to you've got to take responsibility.
I'm waiting on a third one. I feel like there's one more and one more.
Oh yeah, if you'd given me if you'd given me 5 minutes notice, I could have made a list. But
well, I don't really have any other questions, Richard. Is there anything else you wanted to say? I think you really ended it on a high note, like how to, just be the type of person that has their life set up in a certain way that allows success to happen, to free your mind from the things that are unnecessary, like, scaling your database, for example, that give you the freedom to just be the person that can achieve success. And you've done that, and congrats on that.
Thanks. And I speak for my whole team in this, and I talked earlier about how I just enjoy doing it. And I really, I shouldn't speak for other people. The whole team really, I think, is the same way. We're the kind of people that we program because we love doing it, and that we can get paid doing what we love doing is just unbelievable. It's kind of like a professional athlete. A lot of people pay good money to play golf. A few people get paid to play golf.
Yeah, exactly.
We're in those lucky few.
Exactly. Well, Richard, thank you for your time today, and thank you for SQLite and its continued success and the continued success of you. But yeah, I just appreciate your time and hopping on this tiny little podcast for DNS Filter.
Oh, well, thanks for hosting me.